Welcome to Demystifying Math. In this lesson, we're going to be discussing determinants of 2x2 matrices. Before we get started, let's try to understand what a determinant represents. So what we're going to do is start with a system of equations in terms of x and y being the variables. What we're going to do is solve by using the elimination method. So we're going to try to eliminate the variable y. And we can do that by multiplying the first equation by d and the second by negative b. When we do that, the y terms cancel out, and we're left with AD minus BC times x equals ED minus BF. Now just isolating x, we have ED minus BF over AD minus BC. And this actually gives us a formula to solve for the x variable in a system of two equations with two unknowns. Now let's try to eliminate the x variable. We can do that by multiplying the first equation by c and the second by negative a, and then of course add them together. So we end up with y equals AF minus CE over AD minus BC. And again, we have a formula to solve for y. Notice that the denominators of these two formulas are the same. AD minus BC is what we call the determinant of the system. It determines if the system has exactly one solution or not. If the denominator AD minus BC is 0, or if AD equals BC, then the values of x and y will be undefined. And that indicates that the system has either no solution or it has an infinite number of solutions. Let's take a look at some examples. With this example, we have 2x minus 4y equals 2 and 6x minus 12y equals 4. Our determinant in this case, the AD minus BC, is equal to 2 times negative 12. We're just kind of multiplying across. And remember that AD minus BC are the coefficients of x and y. So you have 2 times negative 12 minus negative 4 times 6, which is going to give us 0. So this indicates that our system doesn't have exactly one solution. It could have no solutions, or it could have an infinite number of solutions. So let's try to find out by using the elimination method. What we're going to do is multiply the first equation by negative 3. And when we did that, both the x and y variables canceled out, and it gave us no solution. What you should know about these two lines is that they are parallel lines, so they never intersect, so we don't have any solution. Let's change our example just slightly. So in the second equation, I changed the 4 to a 6. Now when I try to solve this system of equations by again multiplying the first equation by negative 3, we get 0 equals 0. What you should notice about these two lines is that they are the same line. They overlap at every point. So every point on either one of these lines is going to be the same point on the other line. So they have an infinite number of solutions. When you're using the elimination method, you can tell that you have no solution when you get a false statement like 0 equals negative 2. And you get an infinite number of solutions when you get a true statement after you've eliminated the variables, such as 0 equals 0. But in either case, all your variables cancel out. And that's going to happen every time your AD minus BC equals 0. Okay, so we know what a determinant is. Let's practice finding some determinants. So the determinant is written as DET of A, or you could write it as A in what looks like absolute value symbols. So when we're looking at our system, we have the AD minus BC is the determinant of matrix ABCD, which is just your coefficient matrix. Let's find the determinant of 2, 10, 1, 5. So again, we're going to multiply across. So 2 times 5 minus 10 times 1. And we get 0. So this would represent coefficients of x and y in a system of equations where the system of equations is inconsistent, or it does not have exactly one solution. Let's try one more. We want to find the determinant of the matrix 5, negative 4, 3, 7. So we're going to cross multiply 5 times 7 and subtract the other cross, which is negative 4 times 3. In this case, we get 47, which tells us that this system would have exactly one solution. Now what we want to do is use Cramer's rule and solve our system of equations. So we found earlier that x is ED minus BF over the determinant AD minus BC. We know what AD minus BC represents, the determinant of the ABCD matrix. We can do the same thing with ED minus BF. It's going to be the determinant of the EBFD matrix. And in the Y formula, we have AF minus CE, which is the determinant of the matrix AECF. So we can rewrite our formula for x in terms of determinants. So x is going to be the determinant of EBFD over the determinant of ABCD. And y is going to be the determinant of AECF over ABCD. And we want to solve this system using Cramer's rule. So our A is 3, our B is negative 4, E is negative 14, C is 4, D is 1, and F is 13. So looking at our numerator where we have the determinant ED minus BF, that's the determinant of the negative 14, negative 4, 13, 1 matrix. And for our AD minus BC, that's the determinant of 3, negative 4, 4, 1. All right, again, in the denominator, the 3, negative 4, 4, 1 are the coefficients of x and y. In the numerator, we've taken out the coefficients of x and put in the constants, negative 14 and 13, but we kept the coefficients of y. And in this case, we ended up with 2 as being our value for x. Now for y, you're keeping the x coordinates, our coefficients rather, and replacing the y coefficients with the constants. So you still have your 3, 4, which are coefficients of x, and then instead of the y variables in the second, y coefficients in the second column, you have the constants, negative 14 and 13. And the denominator is the same, which we already figured out to be 19, so we just had to rework the numerator, and we end up with 5. So our solution set would be 2, 5, 2 for x and 5 for y. So we're going to check it. So I plugged in 2 for x and 5 for y. In the first equation it worked out, and so in the second equation it also worked out. So that is our solution set. Thank you for tuning in for Demystifying Math, and look forward to doing Cramer's rule with the 3 by 3 matrix.